The cement industry is the world's largest manufacturing industry, and cement is the second most consumed commodity in the world. Its consumption is surpassed only by water. Then again, even cement uses water. Approximately 4 billion tons of cement is manufactured every year. This is equivalent to 20 million truckloads. So how is this cement made? The main ingredient in cement is calcium, which is usually sourced from limestone. Fortunately, 10% of our planet's sedimentary rock is limestone. This limestone is excavated from quarries via drilling, controlled explosions, and the use of heavy earth-moving equipment. Said rock is then transported via trucks and/or conveyors to the grinder. Grinding usually occurs in more than one stage until the rock is fine ground. The composition of limestone may vary. Therefore, in order to maintain compositional consistency, the limestone is pre-blended. One method of pre-blending is to stack the material in the longitudinal direction and reclaim it with a transverse scraper. Portland cement is made up of appropriate compositions of calcium, silicon, aluminum, and iron oxides. And in order to ensure appropriate cement phase assemblages, proportioning equipment is used to mix the limestone with sources of silica, alumina, and iron. The major sources used are clays, shales, and industrial byproducts such as fly ash. The mix is then milled to produce a fine powder known as the raw meal. Generally, the material is also dried in the raw mill. The raw meal is then sent to the kiln, which is a horizontal furnace and countercurrent heat exchanger where heat is transferred from the gas stream to the solid bed. The kiln is the heart of the cement manufacturing process, where the critical clinkering reactions occur. The rotary kiln is the most advanced high-throughput and high-temperature industrial kiln. In modern cement plants, the process configuration includes a preheater tower, which was added in order to improve the energy efficiency of the process. The preheater tower is a series of countercurrent flow cyclones in which the feed material is prepared by heat exchange with hot exhaust gas from the kiln. It usually contains a combustion chamber known as the precalciner, where limestone is calcined. The feed is normally conveyed by bucket elevator to the top of the preheater. The raw material tumbles through increasingly hotter zones and a sequence of physical and chemical changes start to occur, and the raw material fuses to form a clinker at approximately 1500 degrees Celsius. After exiting the kiln, the clinker is cooled. The predominant clinker cooling unit in cement manufacture is the reciprocating rate cooler. The cooler cools the clinker to less than 100 degrees Celsius via heat exchange with ambient air. This heated air is generally then used as kiln and precalciner combustion air as part of the heat recovery system of the cement plant. Portland cement clinker is then ground in mills with gypsum for set control and/or other additives such as slag and limestone where appropriate for performance and permitted by specifications. The cement is then stored in silos or domes before dispatched to the market. In general, shipments of cement range from almost entirely bulk in developed countries to almost entirely sack in less developed countries. Did you know? Due to the large demand for cement, its manufacture is responsible for approximately 8% of man-made CO2 emissions. These emissions contribute to the global warming of our planet, which is detrimental to our way of life. Approximately 1/3 of these emissions comes from fossil fuel combustion, and 2/3 are from calcination of limestone. The cement community is trying hard to mitigate its environmental burden via several actions, such as developing novel low-carbon cements, using alternative fuels, and attempting carbon capture, storage, and utilization.